This conference will now be recorded.
Let me share my screen first and entire screen. I'll be sharing screen. Okay. Today we will be discussing about the creation of cluster using Minikube actually, and then Kubeadm and the cluster architecture. Okay. So, is that audible to you people?
Yes, sir. Yes, sir.
Yes, fine.
Yeah. Yeah. Go to your EC2 machines page actually in your AWS account and launch instances the same way we did for the Docker host. So launch instances. Give here a name Minikube and select the Ubuntu here, Ubuntu, and leave it as it is. This one, AMI, okay. And here, instance type, you select this T2.medium, okay, because Minikube requires some amount of CPU and some amount of memory. T2.micro will not be sufficient to run our Minikube cluster. So click on T2.medium, click on it, and select the key pair that you have created for the Durga, for the Docker host. I'm selecting that one, and I'm selecting the security group, which is select existing security group, which I have given to the Docker host only. I'm selecting that one. Just I selecting that one, and please give in the in this configuration storage section, you give here 25 GB of 25 GB like GB of memory that is required to run your Minikube cluster. Just give that, and just launch an instance. Actually, click on launch instance. Okay. Yeah. Yeah, it is in pending state. Let it come up. Okay. Wait a minute. It will be like in the status check section. Make sure that it should be 2 by 2 health checks passed. It is initializing now. Wait a minute. It's initializing. Let's try to connect to it. Just click on that checkbox of that instance and click on connect. And in the easy to instance connect menu and go to connect. Connect into that instance. Still initializing. Yeah, it has connected to that instance. Move to sudo. First, you need to install Docker, okay, in order to run Minikube cluster. Okay, clear the screen. For the installation of Docker, I will be providing the document like everything. So yeah,
Can you
go to
can you
here.
increase the
Is it
font size, sir? In the font
font
size.
size? One second, one second. Yeah, okay. I've increased that. Mm, just install the Docker with the commands I provided. Just update the packages. Just run one by one command which I will provide. Enter. Okay, here. and this one. Okay, and this one. Copy all this remaining. Okay, it is proper now. Let it execute. It is executing. Yeah, you can see now Docker is in active state and running state. Okay, now what you'll do, just install kubectl. Next, as a next step, as step two, you need to install kubectl. It's a client to connect to the Kubernetes cluster. Like, just install that. Clear the screen first. Give that, and after that, install this kubectl. Downloaded. Just
We are not
downloaded the
able.
binary.
We are not able to
You are
see
not
the
able to.
screen, sir. See the screen, sir. Actually. Okay, now it is coming. Storage. Kubectl. Yes.
Okay, okay, okay. Is it
Tagging
happening
is
for
there, sir.
everyone?
Actually.
Okay. Network is proper.
No, it's visible.
Visible, right? Yeah.
Now it's visible, sir.
Uh,
Yes, sir. Yes.
yeah, yeah. Now just I've installed kubectl. Just check whether the kubectl installed or not with kubectl version -hyphen client. This is a command to check the kubectl installation. Okay, I have installed version 1.29 of kubectl. Okay, just go here and now you need to install Minikube. Okay, just copy this command. Copy this command. Go here, go to your server and execute Minikube installation. You need to take this one. Okay, anyway I'll provide you this document, you can use it. Okay, that has been downloaded. Just execute that binary. Just copy it. Go here, server, and execute this. Okay, setting Minikube. Now what you'll do is you add as a next step, execute this. Okay, 1 second. Go here and you click on exit. Okay, and execute this one. So user mod. And now what you'll do, just execute Minikube start. Just wait a second. It's starting the Minikube. 1 second, it is executing. You can see this is using two CPUs and memory of 2200 MB. That means nearly 2 GB.
Yes, sir. Should be like a medium only, sir. T2 medium only. That one only we need to select, sir, for while creating
No,
machine.
no. That is a minimum. You can select any other
Uh,
machine after that.
T2 micro, sir. Micro is not possible, sir. Micro.
Micro is not possible. See, because it has
Mm-hmm.
one CPU only. It requires two
Mm-hmm.
CPUs.
Okay, sir.
Yeah. Yeah. Now clear the screen. Minikube, you can see done. kubectl is now configured with Minikube cluster and default namespace by default. Like you can see this. Okay, now Minikube is running. Let's clear the screen. Okay, now to interact with kubectl Kubernetes cluster, kubectl is a client actually. How we can say? Let me show in the diagram. Okay, this is a diagram. Okay, one second. Okay, so this is our Kubernetes cluster. Okay, to interact with it, to deploy any applications, to execute some commands on this Kubernetes cluster, and to interact with it, we have something called kubectl, that is a client. With the help of that client only, we will interact with Kubernetes cluster. That is kubectl. That is the meaning of kubectl. It's a client actually. This is a kubectl client, and this is a Kubernetes cluster. Okay, so to interact with it, we use kubectl client that's we installed as part of our Minikube installation. Now check that kubectl get these are the commands that kubectl gives us. Don't worry, as of now we are going to see it very clearly and execute this kubectl get ns, that means namespaces. You can see these are the namespaces present. Yeah, we will be going to discuss what are these namespaces. Okay, these are the namespaces that has been default created when we installed Minikube cluster. So these are the namespaces, and if you want to check the pods, that means applications running, kubectl get pods -n, which namespace. -n means namespace. Which namespace you want to check the pods? Like I want to check the default namespace. Okay, no applications are running, no resources found in default namespace, such that like that. So this is the process that you need to follow in order to install Kubernetes cluster with kubectl. Okay, anyway, I'll be forwarding a document to you. Okay, this is a document actually I already created. Kubernetes cluster creation with Kubeadm. I need to add in this place, and I'll be sending you this document. Just follow this, whatever you want, whether you want Minikube or whether you want like EKS or whether you want Kubeadm, you can install whatever it is actually. So what we are going to see in the class, it's a Kubeadm way. Whenever required, we are going to install with AWS EKS, and we are going to see the EKS way also in the class. We are not going to use the Minikube way because we are not going to get an insights of that. Actually, if we use Minikube, that's why that's the thing actually. So we are not going to use Minikube. Just I want to show you. So whoever want with the less cost, you can use Minikube way. Okay, then let's discuss about the cluster architecture before proceeding with the Kubeadm way, because that requires the clear understanding of the cluster architecture. Okay, so go to where is that diagram? Yeah, here. What is the architecture? Okay, what is the architecture of Kubernetes? Okay, we have two components, two types of nodes. That means in Kubernetes, in Docker, we have called the Docker has Docker host, right? A node like machine as a Docker host. In the same way, in Kubernetes, we will call as nodes. So we have two types of nodes in Kubernetes. One is master node, other one is worker nodes. You can have multiple master nodes, you can have multiple worker nodes actually. Like this. These are the worker nodes, right side one. Let me write it here, worker node. I'll be just indicating with W. Okay, these are the worker. This is the worker node, and this is a master node. I'll be indicating with M. This is a master node, and these are worker nodes. There are some components that are present in master node, and some components that are present in the worker node actually. So what are the different components that are present in master node, and what are the different components that are present in worker nodes actually? So all the worker nodes will be managed by a master node. All the applications that we deploy in the worker nodes, that will be managed by master node actually. So what are the components present actually? So let's discuss about that on the master node. Components on master. Okay, first one is Kube API server. Second one is controller manager. Third one is uh, scheduler. Fourth one is the etcd. Okay, and here controller manager contains different types of, actually I will be explaining in the diagram. And the components on worker node, what are the first component is kubelet. I'll be explaining the what is the functionality of all these components. Second one is kubeproxy. Third one is container runtime engine. Okay, these are the components. These are the components will be present in each and every Kubernetes cluster actually. How these components were architected actually. So first let's discuss about the worker node, like oh sorry, master node. What is Kube API server? Kube API server is a point of contact when we execute any kubectl command. Let me write it here. So this is a Kube API server that will be present on master node actually. So we executed just now, we executed kubectl get pods, right? Get pods. This command, where it will reach first? It will be reached to Kube API server. Whatever we execute the command from our with our client actually, with our client kubectl, that request first reaches the Kube API server actually. It's a point of contact. It's a point of contact. That means whether you are proper user or not, or whether you have right amount of access to the cluster or not, such kind of, and whatever the functionality you executed with the command kubectl get pods, I want to get the pods, this is the functionality I want to perform with the help of command. That functionality also will be listened by this Kube API server. So that is a functionality of Kube API server, and the other functionality is also there. Let me tell you after that. Okay, that is Kube API server. What is controller manager actually? So controller manager, it will be like this. Okay, uh, controller manager will be here, and it contains different controller types of controller managers actually. One is a pod controller manager, pod controller, and namespace controller. There is also node controller. Multiple ways, multiple types are there. Let me draw a few. Namespace means I'll tell you. NS, I am placing as shortcut NS namespace. Okay, namespace controller, and there are node controller also. So yeah, this cube, what are this what is the functionality of controller manager actually? So let's think about power controller manager. Suppose we deploy any application on the Kubernetes cluster in this worker node, and if that application, if it manually or wantedly or by the mistake we delete this application, this controller manager, pod controller manager, will automatically detect that deletion of your application, and then it automatically creates one more application without your interaction. So it is an automatic way of deployment when something is deleted in the your worker nodes actually. So that is a pod controller manager actually. that is a disadvantage that we have seen in Docker. Once any container is deleted in the Docker host, that will not be recreated, right, in the Docker. But here in the Kubernetes, because of the pod controller manager, this application that we deleted manually will also come up with immediately without your manual interaction, without your interaction, that will come up. That is pod controller manager. And what is namespace controller manager? Namespace controller manager is something called, like, we will have something called namespaces in the Kubernetes cluster. Okay, like each like in the something called namespaces that we are going to discuss. That is the isolation of applications between environments. So that we are going to discuss. So we will have a namespace inside like Kubernetes cluster, and each namespace contains something called secret, Kubernetes secret. One second, this is a secret. Okay, so whenever a namespace is created, by default a secret will be created without our manual creation of the secret. That secret creation is done by namespace controller manager. That is a functionality of namespace controller manager, and that is a namespace controller manager. We will also discuss, like we will also see in the live, like whenever we creating namespace, whether a secret is created or not properly. So that's we are going to discuss in the class. So that's a functionality of namespace controller manager. And one second.
Sir, kubectl is interacting with the kube API server, sir. Kubectl command is
Yes,
interacting with kube API server. Okay. Okay,
yes,
sir.
yes.
Okay,
I
sir.
will be I will be discussing how these will interact, Kube API server and controller manager. These will internally interact actually. One
Okay, sir.
second.
Sir, Minikube you are not going to show, sir. Minikube, you install Minikube, that one. We are not doing any
No,
example using Minikube.
we are we are not doing any example using Minikube. Just if you want to show, if you want me to show, I will be deploying one application as Nginx.
Yes, sir. Can you
That's it.
show us, sir? Can you? Yeah, yes.
Yeah, yeah. In the class, I'll be showing. Yeah,
Okay, sir. Please.
because that's no use actually. So yeah,
But show,
yeah,
just please show me, sir.
yeah. I'll show, no problem. Yeah. Other thing that we have under controller manager is node controller manager. Node controller manager. What this node controller manager does? Let me discuss node controller manager. Node controller. What this node controller manager does, whenever we manually delete any node in the Kubernetes cluster, this one node worker node, this one worker node, this one worker node, if I delete any worker node, manually or wantedly or any by mistake, this node controller manager will detect that and create a new new node without any manual interaction. Okay, and our applications will be ready to deploy on that node. Actually, that is a functionality of node controller manager. And what is scheduler? This the next component is scheduler. Let me write it here. Scheduler, what this scheduler does is it checks the CPU and memory resources. Actually, this scheduler will be checking the CPU. Let me delete this. Suppose if we want to deploy any application on the worker nodes, like whether it is worker node 1, worker node 2, and worker node 3, we need to deploy an application. We have executed kubectl apply, that's the command, kubectl apply, like -f and file name.yaml. We have executed that. That request reaches to kube API server. Then it kube API server will request a scheduler to schedule that application. Like what the scheduler does at that time, scheduler will check how much amount of memory and CPU exists in this worker node 1. Okay, it will check the amount of CPU and memory on each worker node. This worker node it will check, this worker node it will check, and the third worker node it will check. If wherever on which worker node if there is a proper amount of creating like a CPU and memory to run that application, and scheduler mentions the kube API server that this is the node that has proper amount of CPU and proper amount of memory, that in order to run that application what the user has requested for, it will kube scheduler will inform that kube API server that this is a worker node, and kube API server will schedule that on that worker node actually. Scheduler will perform functionality like scheduling the application. Scheduler will check all the worker nodes for the resources like CPU and memory, and it will decide on which worker node that application need to be scheduled actually. So that is a functionality of scheduler. Scheduler will decide on which worker node the pod to be the application need to be scheduled. That means the application need to be deployed actually. That is a functionality of scheduler actually. I'll be discussing the how the connection happens between these all these. And next component is etcd. Second, etcd, it's a database. It's a database. One second. It's etcd database. If we deploy an application inside the Kubernetes cluster, and we have deployed like multiple replicas, like what is replica we are going to see. We have deployed an application as multiple replicas. Okay, so what application has been deployed, and what is the application name, how many replicas of that application is deployed, and what is the amount of CPU and memory that application is using, and what is a confidential secret that this application is using. All such things will be it will be stored in etcd. Etcd is a database. It stores the data of the applications and the nodes, and that all the cluster information will be stored inside the database. Suppose we have executed here kubectl get pods, right? Get pods. How we are getting this output? No resources found in default namespace. What is this output? I know how we are getting this. Whenever we execute kubectl get pods, the Kube API server is receiving the request. That request has been received by Kube API server, and Kube API server is requesting the uh, etcd to give all the user like we have executed get pods, like all the applications give me like that. Okay, so Kube API server will request etcd to get the all applications from the default namespace. Okay, it will request Kube etcd, and etcd will get back, like it will get back the data from the etcd and gives us the reply back like no resources found in default namespace. So this output is coming from etcd. That means there is no data. That means there is no application that is deployed on the worker nodes, and that is why we are getting this no resources found in default namespace. That whenever we install like whenever we connect to Kube API server, like this command connects to the Kube API server, kubectl get pods, and Kube API server request etcd to get all the applications that are running. That means we will call as pods in Kubernetes, all the pods that are running in the Kubernetes cluster, and gets the data from the etcd and gives back us the reply actually. So this is the interaction between the Kube API server and the etcd kubectl get pods actually. So this is how they interact. And when we want to deploy any application, to the Kubernetes cluster, how the Kube API server interact actually. We don't have any YAML file as of now to create the cluster actually to deploy an application. What is the command that we use to deploy application? Let me tell you. Kubectl apply hyphen f file name dot YAML. We will use this underscore name dot YAML. This is a file name like to deploy an application. This is an up command. Okay, the application configuration will be given in this file actually. File name dot like any name dot YAML. So this is a command. Whenever we execute this command, how the operation performs by Kube, how the operation performed by Kube API server. Okay, whenever we execute that command, that request reaches to the Kube API server, and Kube API server will contact scheduler. Let me draw it here. One second. Will contact scheduler like this. Will contact scheduler, Scheduler will checks like saying that like the user want to deploy an application, this application, and scheduler checks how much amount of memory present on this node, first node, like worker node, and how much amount of memory present in second worker node, and how much amount of memory present in third worker node. It will check that and gives back the reply to the Kube API server saying that like this is the node that you can deploy that has required amount of CPU and required amount of memory. Then Kube API server deploys that application onto that node actually. So like this, suppose this application want to deploy on this worker node one, like Kube API server deploys that application onto that worker nodes actually. So that is a meaning actually. So that is a how the interaction happens between Kube API server and scheduler. So what is the next thing is Kube controller manager. This controller manager is for controlling the entire Kubernetes cluster. Whenever there is something called a kubelet inside this, let me discuss that. One second. We will discuss about Kubernetes, this one, controller managers, because you need to understand the kubelet in order to understand this pod controller and namespace controller and node controller. Okay, there will be something. Let's go to the worker node components as of now. Okay, there is something called kubelet here inside each worker node. Will having some kubelet. Okay, let me draw it here. Kubelet, and here also it will be there. One second, I need to take this. This is kubelet, and I'll also draw this one. I'll be telling you what is this kubelet. Okay, and I'll also write it here, kube proxy. This is a kube proxy. This is kube proxy actually. Suppose scheduler informs this kube API server like this is the application that need to be deployed uh, on this worker node, first worker node. Then kube API server, what it does? Kube API server will interact with kubelet on on that worker node, and by saying that please deploy this application on your worker node, then kubelet deploys that application on this worker node. Kubelet is a master, like it's a captain of this on their worker node actually. So this is a kubelet, whatever it is, like if something happens, uh, whatever the requested by the Kube API server, whatever the request the Kube API server gives to the kubelet performs that on that worker node and sends the backlog reply saying that that application has been deployed on my worker node, like that. And that is a functionality of kubelet. Whatever the things happening on that worker node, that will be known to the kubelet will be informing to the Kube API server, like that it will be actually. So this is a master, like it's a captain in that worker node actually. So like that. So kubelet, okay, this is a kubelet. Whatever the things happening in this worker node, that will be informed to the kubelet, like that will be informed by kubelet to the master node actually, to the Kube API server. That is a kubelet. Okay, suppose now let's discuss about controller manager. Suppose if I delete this pod, if I delete manually this pod, okay, now what it will happen? Kubelet automatically detects that the pod has been deleted on an application, or an pod has been deleted in my worker node, will automatically detected by kubelet, and it will be informing that to Kube API server, like this. It will be informing that to Kube API server. Kube API server informs to controller manager saying that the pod has been deleted. controller manager will inform pod controller. That means it's a pod, right? That's why it will interact with the pod controller manager, and pod controller manager contact the scheduler that it needs to be scheduled actually. That means it need to be deployed because of the deletion that we did. It contacts the scheduler, and scheduler will send the information back to on which node it need to be deployed. Okay, on which node it need to be deployed, it sends back to the kube controller manager. Okay, and then the request goes back to the controller manager like this, and the request goes back to the kube API server, and kube API server performs again deployment on the worker node that is selected by scheduler actually. So this is the pod controller manager. So something happens, or by manually or by like wantedly or mistake, if I delete some pod on this worker node, that will be detected by kubelet. Kubelet will be informing that information to the kube API server. Kube API server will be informing that kube controller manager that that pod has been deleted. Kube controller manager will be informing that to particular uh, pod controller, and then pod controller will be asking the scheduler on which node I need to schedule that pod, like on which node I need to deploy that pod, and it scans all the nodes for the right amount of CPU and for the right amount of memory, and detects a node and sends back the node information to the pod controller and back to the controller manager and back to the kube API server, and that kube API server contacts the kubelet of that node which has been detected by, like, which has been selected by scheduler, and that kubelet will be deploying that application onto that node actually. So that is how they interact actually in the master node. In the master node, that is how they interact actually. So once the application is deployed on the master, like, worker node, kube API server will update the etcd, that this application data will be updated in the etcd database, and that data will be stored actually. So that is the thing. That is a kubelet. Kubelet is the captain, or the owner of that ship, of that particular node actually. So that's a kubelet. Let me delete this. Any questions up to here, please? Please, this is our cluster architecture to understand well. Any questions up to here?
Sir, but sir, this process completely when we give like a kubectl command, sir, then only this all process will
Yeah.
be going on, sir, right?
Yes, yes.
When we
Internally,
give
it will
like
be going on.
kubectl command. Mm, mm,
Yes, yes. When you execute some command with kubectl, all this process will be
mm,
internally going. That will not be visible to us
mm,
actually. How the application deployed on the Kubernetes cluster will be
mm.
following this process actually.
Okay, sir. Okay. How the application?
Yeah.
This
Any
kubectl is for
questions?
the every worker node, sir. Kubelet is the every worker node. It is.
Yeah, yeah. Kubelet is present in every worker node.
Mm. Sir, what exactly scheduler does it? I got some confusion. Scheduler.
Scheduler is like, it will be checking, like, this kube. I have
Mm,
requested to deploy an application like this kubectl apply
mm,
-f. This is the way we need to deploy an application on the Kubernetes cluster. Okay, so whenever we requested for deploying an application on the Kubernetes cluster, this request will be listened by kube API server first. This is the first case. Okay,
okay, sir.
kube
Yeah.
API server,
Mm,
kube API
mm,
server will contact scheduler.
mm,
The
mm,
scheduler will check each and
mm,
every worker node, like, how much amount of CPU and memory is there with you, and how much amount of CPU and memory is there with worker 2, and how much amount of
mm,
CPU and memory is there with worker 3. It will be checking that
mm.
how much amount of resources are present on that particular node.
Resources,
if,
sir. Okay.
if it
Okay.
yeah, if it finds a particular
Mm,
resource, if it finds a particular resource, like, this application needs some amount of memory and CPU, right, to run. If it
mm,
finds that amount of CPU and memory on any worker node, it will be informing,
mm,
scheduler will be informing that this is a worker node that you need to deploy. So kube API server will contact that worker node
mm,
and deploy that application. It is if this scheduler functionality is to check the worker nodes
mm,
for the scheduling,
mm.
of our applications.
Okay, sir.
Any questions? We need to discuss kubeproxy and container runtime. Any questions, please? Okay. Suppose we have seen an example in our Docker when we are discussing about Docker, we have deployed an WordPress application that need to be communicated with MySQL, right? So how it works in case of Kubernetes actually. So I deployed an application on this worker node one actually, that is WordPress application has been deployed here. Okay, let me put it here. This is a WordPress application that is been deployed, and this is the MySQL application that is been deployed. Okay, that means MySQL database. Okay, MySQL database that is been deployed in this second worker node, and this WordPress application is been deployed this first worker node actually. So in order to work this this WordPress need to be communicated with MySQL database, right? So this WordPress need to be communicated with MySQL database. This WordPress need to be need to store that data which is generated by user to the MySQL database, right? So how the communication establishment will be there between the applications on different worker nodes actually? That is because of kubeproxy. Kubeproxy enables the communication between the applications present on different worker nodes actually. That will be present like that will be because of kubeproxy. That is internally done by something called IP tables. That's a Linux one that is already configured when we create a Kubernetes cluster. Okay, because of that one, so kubeproxy will be able to establish a communication between the different applications on different worker nodes actually. So that is a functionality of kubeproxy. Kubeproxy is a component in on the worker node. It will present in each worker node that is used to establish a communication between different applications on different worker nodes actually. That is a kubeproxy. Okay, that is kubeproxy. And what is a container runtime engine? In our case, we have seen the Docker. Docker is a container runtime engine. That means we will be running our applications as containers with the help of Docker. So with the help of Docker, we are running like as containers, right? So that is a container runtime engine. As we discussed earlier, we have multiple container runtimes available in the market: Docker, Cryo, and Rocket, and Container D. Okay, so such kind of things available in this container runtime engine need to be run on every worker node actually. This need to be run here actually, so this need to be there here. Okay, this need to be there here. So container runtime engine will also be there, whether it is any container runtime engine, it will also be there in this master node. Okay, so container runtime engine is to run our application as containers, and it will be present on every node in the Kubernetes cluster actually. So that's the thing actually. So that is a container runtime engine. CRE. Okay, one second. CRE container runtime engine. CRE. CRE. This is a container runtime engine that is present on every worker node actually, on master node also. One second, I'll put it here also. So this is a thing actually, and whatever, like if you create a Kubernetes cluster with AWS EKS, this all things, this master node will be maintained by AWS people only. You no need to worry. It will not be visible to you also. All these components will not be visible to you. This will be maintained by uh, AWS people, that is managed Kubernetes EKS. Okay, and you can able to deploy an applications on these worker nodes, and you will be able to see the kubelet and kubeproxy and container runtime engine in your by logging into that machines. I'll be also showing you when we are going to discuss about AWS EKS, how they are running inside that. I'll be showing that. So you will not be able to view this like master node components if you use AWS EKS that will be internally managed with the help of with like AWS team only, and you can only able to view this worker nodes. Actually, that is a thing. Okay. Any questions regarding the Kubernetes architecture? Any questions, please? Any
Whereas
questions?
in
Any questions?
sir, Minikube Kubeadm, we need to create, sir, all these things like a Kube API
Yeah, yeah.
server
Yes, yes. All these things will be visible.
visible, sir. But whereas in EKS AWS, we can't see.
We cannot. We cannot. That is managed by
We cannot.
AWS team.
Yeah.
Yeah.
Communication is happening through two proxies, sir, from the one port to another port, like this, from one node to
Yeah, yeah.
another node.
Yes, yes. Yes, yes. The communication between applications will be happening through the kube proxy. That is
Two
done.
proxies. Mhm.
That is done because of that is the kube proxy can also establish a communication because of IP tables. Something it's a Linux in
Mhm.
configuration that is internally performed when we create a cluster.
Mhm.
Okay, that is the case actually. So
Okay, sir.
it's a, IP tables is a kind of a firewall that I can say.
Mhm.
Yeah,
Okay, sir.
that's a different concept. Yeah. Any questions? Any questions? Any questions? Okay. This is a Kubernetes architecture. Anyone pasted anything in chat? Let me check that 1 second. Okay, okay. I'll be doing that, Deepak. No problem. To use Minikube, also kubectl installation mandatory. Yes, to install kubectl, like to install Minikube, also kubectl is mandatory because that's the client to interact with Kubernetes cluster. If node is deleted while auto recreation of the node from where it will, if the node is deleted while auto recreation of the node from where will it again get the application code. It will be getting the application code like from the Docker image only. We have we have discussed in the Docker, right? Like our the application code will be converted as Docker image, and the Docker image will be converted deployed in our Kubernetes cluster. From there only it will be getting. So please don't delete. Yeah, I'll be not be deleting. So please upload case. Yeah, I'll be uploading. No problem. I'll uploading that. Yeah. Uh, this is a cluster architecture. Okay, these are different components present in uh, cube Kubernetes architecture actually, Kubernetes cluster actually. So this is a thing. Okay, now mm, we have we have we need to also see a Kubeadm way of deploying Kubernetes cluster. Okay, let me check that. Yeah, I need to reload. Okay, now to create a Kubeadm way of creating cluster, once again let me take the screenshot. In order to create a Kubernetes cluster, like a Kubeadm way, I want to create a Kubernetes cluster with one master and three worker nodes with Kubeadm like this. Each and every worker node, whether it is master and whether it is worker, we are going to use only one type, that is T2.mic, T2.medium or T3.medium or what. This one is T2.medium. Yeah. 1 second, let me write it here. We are using T2.medium on of each node that we are going to deploy with Kubeadm. Okay, that is t2.medium. Once again, we need to create a 4 instances. That means 4 nodes. One is master and 3 are worker nodes. Actually, just launch an instance. Just give number 4 here. Number of instances you can see here. Number of instances, how many instances you want to create. That is 4 you can create. And go here, select an Ubuntu machine. Okay. Then you need to select this t2.micro. Instead of that, you need to select t2.medium. Okay, t2.medium you need to select. Okay, then select your key pair. Select your key pair. That is, I want to select my key pair and select an existing security group. Okay, select this, which has like all the permissions, and give here how much amount of CPU like memory is required. I'm giving 25 GB for each node. Actually, for each node I'm giving 25 GB of 25 GB for first node and second node, third node, fourth node, like that. Okay, just launch an instance. Just click on it. Everything right. Yeah, t.medium and Ubuntu AMI, Ubuntu server, and just name. I'll be giving the name after creating the instances. Just click on here. Yeah, it has been created. One second, view instances. Now I want to delete this Minikube. Okay, I've shown you right. Uh, one second. I want to stop because you people asked to show deployment in the Minikube, right? Just I will stop. I'll be showing in future classes. Just stop that. Yeah, let it run. This is one node. One second. This is this one, this one, this one, this one. Yeah, these are the 4 nodes. Let me put names for them. Master node. Okay, right mark. Worker 1 and worker 2 and worker 3. Now let them install, like let them initialize. It's initializing. Let me open the master. Connect. Let me close this. Okay. Go here. Just this is yeah, it's still initializing. It's taking some time. I closed. Let me open. Connecting. Yeah, it's initializing. Let it complete. I'll also open the worker node. This is a worker node 1. I'll be differentiating this. You need to differentiate this. Okay, one second. Worker node 2 I want to open. And I'll be placing the worker node 2 here. That's the tab. Worker node 3. Connect to this worker node 3. And one second. I'll be placing the worker node 3 at the last. Okay, now this is a master. This is a worker node 1, this is a worker node 2, and this is a worker node 3. Okay, let it connect. Okay, now sudo su hyphen, yeah, click on, go to sudo access, like root user access. This is same. Whether it is connected to Docker or what. This is worker 1. One second. This is 2. And this is worker 3. And looks like this is Docker. Let me close this. And instances. Master. Go here and connect. Okay. Connect to this. Connect. I have collected the commands you need to run. Let it connect. Clear the screen. That's worker node. Okay. You can see here on which node I'm executing the commands. This is master. You can see it here down master. Go to root access, clear the screen, create a file like unique uni ue.sh is a shell script unique.sh. Create a file here, and I will be giving you the content. One second, where is that? On it, what you need to paste. Okay, Minikube is this, Kubeadm is this, unique this. Okay, copy this content, command C. Okay, and go here, paste it here, command V. Okay, all the content was being pasted. Okay, just escape :WQ, save that, and you do that paste like in every node actually. Vi unique .sh. Okay,
What is
insert
this one, sir?
mode, and
Unique.sh. What is this file, sir, actually?
this will like all these components, like what we discussed in the Kubernetes architecture, right? That will be installing all the
Mm.
components actually. So whatever the cluster runtime, like container runtime engine, kubelet, kubeproxy, all these things actually.
Mm.
So yeah, and the container runtime engine also will be deployed, as I say here in the
This is the
process.
Minikube, sir, or Kubeadm, sir? This one is we are doing actually right now.
No, this is Kubeadm, not Minikube.
Okay, Kubeadm. Okay.
Minikube, Minikube we already seen, right?
Yes, sir. Yes, sir. Just okay. Creation we have
Yeah,
seen, sir. But,
yeah, that only creation only. Now also I'm showing the creation of with Kubeadm.
Kubeadm, sir. Okay.
Yeah, don't worry with the script. It's taken from the documentation of Kubeadm. Um,
Okay, sir. Yeah.
escape :WQ, enter, and paste this. Clear vi just paste all the script. Okay, escape : we can also upload to S3 and we can pull it here, but like if you are not familiar with S3, it's another problem. So that's why I'm pasting like this. Clear the screen. Okay, execute that script. Actually, that is shell script. You need to execute. You can see the unique.sh is there, and give the like check the permissions of that ls-la. You can see this unique uh, like unique.sh does not have execute permissions. Like you can give chmod. Okay, just give 777 and unique.sh tab. One second, unique.sh, give that, and you can see now it will be in executed, like it will be having some permissions. uh, One second, execute that, and okay, you can check it has some executed permissions. And now execute that one. Actually execute this shell script dot slash unique dot sh. One second, we got double slashes. Enter. One second, bad no such file or directory. ls uniquesh, and I1 pick fall. Yeah, this is the problem that we face if we copy and paste. Clear the screen. Okay, in bash, let's see the interrupter knows a file directory. Yeah, I'm trying to install some bash, I think. Yeah, yeah, we will be continuing this. It's already time. It will take another half an hour to create this cluster with the Kubeadm way. Actually, we'll be continuing this in tomorrow class. Actually, I have all the shell script ready to create a cluster. Okay, we are facing some problems if we copy and paste like this. I'll be uploading like to S3 and copying, like download it here and execute that shell script actually. So any questions up to here, please ask.
Minikube, you can't create like a cluster, sir. Can you create the cluster in Minikube using cluster?
No,
Is
no,
it
Minikube
possible
is a
using
single
the
node.
Minikube, sir? Single node
See,
only. Okay,
it's a
okay.
single node only, one node only. All the master and all the workers will be
Mm.
present in one node only. You cannot uh, like
Mm-hmm.
create multi-node clusters like that with Minikube.
Only one single node only. Master and worker node is
Oh, yeah, yeah, everything is one node only. Whatever applications you want to deploy is only in one node.
one node only.
Yeah.
But self-healing is possible, sir, in that case. Suppose if the node is deleted, automatically create like a new node and like
No, no,
even
no, no.
prod also
Self-healing
create.
is not possible in
Mm.
that.
But Kubeadm it possible, sir. The Kubeadm
No, no,
it's possible, right? Sir?
Kubeadm is also not possible because it's not part of auto-scaling of Kubernetes. It is possible with that one. Which one?
EKS,
EKS, AWS EKS.
EKS
Yeah,
one.
yeah.
Okay, sir.
That scenario I want to such kind of scenarios I want to show with the help of
Mm.
EKS. I cannot show that scenarios in case of this one actually. Such
Mm-hmm.
scenarios I need to create a EKS cluster and I need to show that scenarios.
Okay, sir.
Yeah. That's why the people uses in the industry EKS only, not this
Yes,
Kubeadm
cluster.
or not
Sir,
this
if it is the Azure, sir,
Minikube or nothing. Yeah.
Azure means in that case what they are using, sir? For example, in AWS, EKS, AWS, right?
AKS.
In
Yeah,
if
in
it is
Azure they
Azure,
will be using AKS. AKS,
AKS. Okay.
AKS. Az Azure Kubernetes Service. And in
Mm.
GKE, like Google Cloud, they'll be using GKE, Google Cloud Engine.
Google Cloud Engine. But all are
Google
similar, sir.
Kubernetes,
Just
sorry.
like a same
Yeah,
processor, just like a same process. Mm.
everything is similar. Everything is Kubernetes clusters only. The interaction is also similar. Kubernetes commands also similar, and the concepts also
Mm-hmm.
similar. The
Okay, sir.
services they provide, like it's belong to Azure, it belongs to Google Cloud,
Mm.
and it belongs to like AWS like that.
Okay.
Yeah,
And sir, without Kubernetes, any Docker is like this, sir? Like any Docker services like this? Without
I did
Kubernetes,
not
sir.
understand the question, please. Without
No, no, sir.
Kubernetes.
Just like we have like a EKS and AKS is there, na, sir, like that. Any Docker
Okay.
service is there like that, actually?
No, 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 no. Docker
No.
service is not there, but there is a
Mm-hmm.
service in AWS, but we'll
Mm-hmm.
not call as Docker service. That service is called as ECS, Elastic Container Service. There also you'll be running our applications as containers only, like it's a kind of Docker as you say, but we'll not call as Docker. We'll call as
Mm.
ECS.
Okay, sir.
Yeah. That is a way that people use it to
Mm.
follow if they deploy
Mm.
before Kubernetes actually.
Before.
Now also
Mm-hmm.
people are following that in few companies
Mm.
who are
Mm.
not migrated to Kubernetes, they are using ECS, and who are migrating to Kubernetes, they are using Kubernetes.
Okay, sir.
Yeah. Any questions? Any questions? Anyone in chat? 1 second. If worker host itself deleted, then image will also be deleted with it, as you mean all images will be available on master node itself. Yeah, if worker node is deleted, the 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 whatever the scheduler is there, right? The pod controller is there, right? That will be automatically detected that the deletion has happened, and that will be creating it will be storing the data in the etcd database, right? And it will be checking the database, and it will be automatically creating the new application with that data present in the etcd. Like this is the image, and this is the these are the configuration that you need to be created, and such kind of things that will be checked by scheduler or like a pod controller, and that will deploy that application and informs the Kube API server, and Kube API server deploy that application on the worker nodes. Actually, that information you'll be getting from etcd database. Yeah, there are different types of there are different ways of pulling the images. Actually, you can directly pull the images from aws ecr, or like ecr also you can use, and private registry docker, we have seen the docker private registry, right? From there also you can pull the images, and public registry also you can pull the images. Whatever registry it is, you can pull the images. But if you want to pull the images from private registry, you need to create some extra configuration, because that private registry will be private to you or private to your organization only. Only you or your organization need to be accessing that one. Actually, that's the thing.
From the JFrog also we can pull, sir. JFrog and Nexus repositories also.
JFrog and Nexus is meant for different thing. Actually, JFrog and Nexus is to store the artifacts, like if you
Even
want,
in our
suppose
organization, yes, sir. Actually, we are storing like
suppose
images in the JFrog, and we are pulling that images
uh-huh,
in the Kubernetes configuration, sir. That is happening.
that is opening. Yeah, generally
Mm.
people will be storing the artifacts like jar files with different
Mm,
versions,
mm.
and Nexus
Yes,
also
sir.
they'll
Yeah.
be storing like that. But in your case, it's different. Looks like we will not store. That's not meant for that. Actually, storing images. Storing images will be meant for only this one. If that
Indeed.
is the way you can pull. Actually, what's case you can pull the
Mm-hmm.
image in the same way you can download the jar file, right? In the same way you can
Mm.
download the image also.
Images also, sir.
But
But generally,
yeah,
Docker
this is
images
the
are
first.
pulling from the Docker registry only, sir. Docker registry only. Like,
That is decided by your organization. Okay, some people
okay.
will be storing the Docker. Some people will be storing their Docker images in Docker like ECR, AWS ECR.
Mm.
Some people will be storing in their private registry, like we have seen the Docker registry, Docker private
Mm.
registry, and some people will be storing like anywhere they want, and that will be decided by your organization.
Okay, sir.
Yeah. Any questions? Yeah, if not, we'll closing tomorrow, and we'll be seeing the Kubeadm way of creating cluster. It takes so much time. So, and yeah, we will be proceeding tomorrow. Okay. Have a good day, everyone. Thank you.
Thank you, sir.